This is not, let me adjust my mic here. This is not necessarily an article, but it's definitely worth reading. So this is NVIDIA's Blackwell architecture, the technical brief. I scanned through it and I wanted to kind of get in and kind of read it thoroughly. And hey, I think it's good to share with you all as well. So I'm going to go into this and read this. Obviously, this video is going to be, or this time spent doing this is going to be a little bit longer, but I do think it's something worthwhile for sure. So let's just get right into it. NVIDIA Blackwell architecture technical brief, built for the age of AI reasoning. I'm not going to go through all the table of contents. You can do that on your own. And as I read through this, I know there are a lot of different diagrams and so on. I might stop on one or two of them, but for the most part, I'm just going to read through this and go from there. Just want to make sure, I'm just checking to make sure that I can go through the entire document and it will all be on the screen. So if you don't have any issues at all, give me 1 second here. All right. I believe that you should be able to see this well. Yep, you can. And so yeah, all right. Good deal. Let's start at the top here. NVIDIA GB300 NVL72, built for the age of AI reasoning. For years, advancements in AI have followed a clear trajectory through pre-training scaling. Large models, more data, and greater computational resources led to breakthrough capabilities. Building more intelligent systems is no longer just about pre-training bigger models. Instead, it's about refining them and making them able to think and reason. By refining AI models to specialized tasks, post-training scaling improves models to deliver more conversational responses. Tuning models with domain-specific and synthetic data enhances their ability to understand nuanced contexts and provide accurate outputs. Synthetic data generation has no upper limit, which translates to a significant need for compute resources in post-training scaling. Now, a new scaling law has emerged to amplify intelligence: test time scaling. Also known as long thinking, test time scaling dynamically increases compute during AI inference to enable deeper reasoning. AI reasoning models don't just generate responses in a single path. They actively think, weigh multiple possibilities, and refine answers in real time. This shift towards post-training scaling This shift towards post-training scaling and test time scaling demands exponentially more compute, real-time processing, and high-speed interconnects. Post-training can require 30 times more compute than pre-training to develop customized derivative models. Interesting. And long thinking can require 100 times more compute than a single inference pass to solve for incredible complex tasks. I'm going to highlight that. I can't highlight here, but that would be a good paragraph to highlight. Enter NVIDIA Blackwell architecture, built with the specific purpose of handling data center scale reasoning AI workloads with up to 30 times the energy efficiency of the prior NVIDIA Hopper GPU generation. And it's good to know that as the technology is improving, right, one big thing that they're looking at is also energy efficiency, right? It's huge. I mean, GPUs already use much more energy than CPUs. And then when you have GPUs, a cluster of GPUs, and you got hundreds, thousands of them, obviously you're going to get a super exponential increase in energy usage. And so the ability to make these GPUs much more efficient saves tremendously on power usage from direct energy or, from cooling, etc. This technical brief introduces the benefits of NVIDIA Blackwell in detail, including the Blackwell Ultra GPU, the GB300 NVL72 rack scale system, and the HGX B300 server. GB200 NVL72 and HGX B200 system information is also included. NVIDIA Blackwell and Blackwell Ultra overview. The NVIDIA Blackwell and Blackwell Ultra products are designed to address the needs of ever-increasing AI complexity, including large model sizes and AI reasoning, with a long list of new innovations. With NVIDIA Blackwell and Blackwell Ultra products, every enterprise can use and deploy state-of-the-art LLMs with affordable economics, optimizing their business with the benefits of reasoning AI. At the same time, NVIDIA Blackwell and Blackwell Ultra products enable the next era of AI models, supporting high throughput with real-time performance, something unattainable without Blackwell's architectural innovations. This is NVIDIA Grace Blackwell Ultra Super Chip and Connect X8 Super NICs. NVIDIA Blackwell Architecture Innovations. The Blackwell architecture introduces groundbreaking advancements for AI reasoning and accelerated computing with Blackwell and Blackwell Ultra products. The incorporation of a new second-generation transformer engine alongside faster and wider NVIDIA NVLink interconnects propels the data center into a new era, with orders of magnitude more performance compared to the previous architecture generation. Further advances in NVIDIA confidential computing technology raise the level of security for AI inference at scale without compromising performance. And NVIDIA Blackwell's new decompression engine, combined with Spark Rapids libraries, delivers unparalleled database performance to fuel data analytics applications. And NVIDIA Blackwell's multiple advancements build upon generations of accelerated computing technologies to define the next chapter of reasoning AI with unparalleled performance, efficiency, and scale. Transformer engine, 5th generation NVLink, RAS engine, the secure AI, and decompression engine. A new class of AI GPU built with 208 billion transistors. These numbers always blow my mind, but it's interesting. 208 billion transistors, more than 2.5 times the amount of transistors in NVIDIA Hopper GPUs, and using TSMC's 4NP process tailored for NVIDIA, Blackwell is the largest GPU ever built. NVIDIA Blackwell achieves the highest compute ever on a single chip, 20 petaflops. This architecture can incorporate a significant amount of computing power by merging NVIDIA Blackwell by merging two GPU dies. Each of the two GPU dies are the largest die possible within the limits of reticle size, as big as can possibly be built today. The two dies are connected and unified with a single 10 terabyte per second chip-to-chip NVIDIA high bandwidth interface, or NVHBI, providing one fully coherent chips. So this is two GPU dies. Two dies are connected via a 10 terabyte per second chip to chip high bandwidth interface. The Blackwell architecture is much more than a chip with high floating point operations per second computational rates. It continues to build upon the benefits from NVIDIA's rich ecosystem of development tools, CUDA-X libraries, over 4 million developers, and over 3,000 applications scaling performance across thousands of nodes. The new NVIDIA Blackwell Ultra GPU is built for the age of AI reasoning and enhanced compute and increased memory. The GB300 NVL72 delivers 1.5 times more performance than NVIDIA GB200 NVL72, as well as 50 times more AI reasoning productivity, 35 times faster AI reasoning inference, and 30 times higher energy efficiency, and 25 times lower costs per token compared with NVIDIA Hopper systems. And there was a video that I put out where Jensen said, if you're looking, I'm trying to remember it, but if you're, one of the KPIs that you should be looking at is the cost per token, right? And basically looking at that as a large factor of profitability for your AI operations. And so as you see here, it says 25 times lower cost per token as well than the NVIDIA Hopper system. Blackwell Tensor Core architecture. Tensor cores are specialized high-performance compute cores for matrix multiply and accumulate math operations that provide groundbreaking performance for AI and HPC or high performance computing applications. And so at the end of the day, kind of at the ground level, rubber meets the road level, is matrix multiplication. And that's, what allows AI to think as intelligence. So when we're talking about neural networks and all those sorts of things, at the base of it is matrix, a lot of matrix multiplication, a lot of math. Tensor cores operating in parallel across SMs in one NVIDIA GPU deliver massive increases in throughput and efficiency compared to standard floating point integer and FMA or fused multiple accumulated operations. Tensor cores were first introduced in the NVIDIA Tesla V100 GPU and further enhanced in new NVIDIA GPU architecture generations. As generative and reasoning AI models increase in size and complexity, it's critical to improve training and inference performance. To meet these compute needs, new 5th generation Tensor Core architecture in Blackwell supports new number formats such as FP4, including community-defined microscaling, OCP formats. The Blackwell architecture supports all the data types and numerical formats listed in Table 1. I'll be honest, I don't really know and understand a lot of these data types, but it's something that I'll look into more. 2nd generation transformer engine. Blackwell introduces the new 2nd generation transformer engine. The 2nd generation transformer engine uses custom Blackwell Tensor Core technology combined with NVIDIA Dynamo, TensorRT LLM, and NeMo framework innovations to accelerate inference and training for LLMs, AI reasoning, and mix of experts models. The Blackwell transformer engine utilizes advanced dynamic range management algorithms and fine-grained scaling techniques called micro-sensor scaling to optimize inference performance, accuracy, and enable FP4 AI. This doubles the performance of Blackwell FP4 Tensor Core, doubles the parameter bandwidth to the HBM memory, okay, and doubles the size of models supported per GPU. Innovations in Dynamo and TensorRT LLM, including quantization to 4-bit precision, custom kernels with expert parallelism mapping, and disaggregation, are democratizing today's MOE models for real-time inference, using less hardware and less energy with less costs. For training, the second generation transformer engine works with NeMo framework and Megatron core innovations in new expert parallelism, that word always gets me, parallelism techniques that combine with other parallelism techniques and fifth generation NVLink for unprecedented model performance. Lower precision formats open possibilities for further acceleration of large-scale training. With the Blackwell second generation transformer engine, enterprises can use and deploy state-of-the-art AI reasoning models with affordable economics, optimizing their business with the benefits of generative AI. NVIDIA Blackwell makes the next era of AI reasoning models possible, supporting both training and real-time inference. Attention layer acceleration. The Blackwell Ultra GPU provides a two times the speed up over Blackwell GPUs for attention layer compute, with new instructions to improve the performance of long input sequences. Doubling the attention operations using the Blackwell Ultra GPU architecture enhances AI performance by reducing latency, enabling faster and more intelligent decision-making for AI reasoning models. This acceleration also helps lower compute costs by reducing processing time, leading to energy and infrastructure savings. Enterprises can scale more efficiently, handling a larger workloads with the same resources, ultimately driving greater efficiency, cost savings, and a competitive advantage in AI-driven business operations. Performant, confidential computing, and secure AI. Generative AI holds tremendous potential for businesses, optimizing revenue, providing business insights, and aiding in generative content are only a few of the benefits. But adoption of generative AI can be difficult for businesses that need to train them on private data that can be subject to privacy regulations or includes proprietary information. NVIDIA confidential computing capabilities extend the trusted execution environment, or T, beyond CPUs to GPUs. Confidential computing on NVIDIA Blackwell was architected to deliver the fastest, most secure, and attestable evidence-based projections for LLMs and other sensitive data. NVIDIA Blackwell introduces the first TIO capable GPU in the industry, while providing the most performant confidential compute solution with TIO capable hosts, as well as inline protection over NVLink, providing confidentiality plus integrity. Blackwell confidential computing delivers nearly identical throughput performance as compared to unencrypted models. Customers can now secure even the largest models in a performant way, in addition to protecting AI intellectual property, and securely enable confidential AI training, inference, and federated learning. Fifth generation NVLink and NVLink switch. Unlocking the full potential of exascale computing and AI reasoning models hinges on the need for swift, seamless communication among every GPU within a server cluster. The fifth generation of NVLink scales up to 576 GPUs. Wow. To accelerate performance for reasoning AI models thanks to NVLink switch chips built with it. Fifth generation NVLink doubles the performance of fourth generation NVLink in NVIDIA Hopper, while the new NVLink in Blackwell and Blackwell Ultra GPUs also uses two high-speed differential pairs in each direction to form a single link as the Hopper GPU. NVIDIA Blackwell architecture doubles the effective bandwidth per link to 50 gigabits per second in each direction. I'm going to say that again. While the new NVLink in Blackwell and Blackwell Ultra GPUs also use two high-speed differential pairs in each direction to form a single link as in the Hopper GPU, NVIDIA Blackwell architecture doubles the effective bandwidth per link to 50 gigabits per second in each generation. Blackwell and Blackwell Ultra, hold on a second. Had some noise there, I didn't want you to have to hear. Blackwell and Blackwell Ultra GPUs include 18 fifth generation NVLink links to provide 1.8 terabytes per second total bandwidth, 900 gigabits per second in each direction, 1.8 terabytes per second of bidirectional throughput per GPU is over 14 times the bandwidth of PCIe Generation 5, ensuring high-speed communication for today's most complex large models. Within a 72 GPU NVLink domain, 130 terabytes per second of aggregate bandwidth is transferred. That's more data movement than the entire internet. The NVIDIA NVLink switch enables 130 terabytes per second GPU bandwidth, and in let me read that again. The NVIDIA NVLink switch enables 130 terabytes per second GPU bandwidth in 172 GPU NVLink domain for model parallelism and delivers 4 times bandwidth efficiency and new NVIDIA scalable hierarchical aggregation and reduction protocol support. NVLink and NVLink switch use together support clusters beyond a single server at the same time, impressive 1.8 terabytes per second interconnect. Multi-server clusters using NVLink switch can scale GPU communication in balance with the increased computing, enabling the GB300 NVL72 to support 9 times the GPU throughput as compared to a single 8 GPU system. Decompression engine. Data analytics and database workflows have traditionally been slow and cumbersome, relying on CPUs for compute. Accelerated data science can dramatically boost the performance and end-to-end analytics, speeding up value generation and time to insights while reducing costs. Databases play critical roles in handling, processing, and analyzing large volumes of data for data analytics. Blackwell architecture's new dedicated decompression engine can decompress data at a rate of up to 800 gigabytes per second. In combination with 8 terabytes per second of HBM's 3E high bandwidth memory using one GPU in GB200 and the Grace CPU's high-speed NVLink C2C or chip-to-chip interconnect, Blackwell and Blackwell Ultra accelerate the full pipeline of database queries for the highest performance in data analytics and data science, with support for the latest compression formats such as LZ4, Snappy, and Deflate. NVIDIA Blackwell is 18 times faster than CPUs and 6 times faster than NVIDIA H100 GPUs for query benchmarks. And so here is the diagram of queries per second. For the x86 regular CPU, that's 5. XGX H100, that's 15. And then for the GB200, it's 90. RAS engine. Blackwell architecture adds intelligent resiliency with a dedicated, reliable availability and serviceability engine to identify potential faults that may occur early on to minimize downtime. NVIDIA's AI-powered predictive management capabilities continuously monitor thousands of data points across hardware and software for overall health to predict and intercept sources of downtime and inefficiency. This builds intelligent resilience that saves time, energy, and computing costs. NVIDIA's RAS engine provides in-depth diagnostic information that can identify areas of concern and plan for maintenance. The RAS engine reduces turnaround time by quickly localizing the source of issues and minimizes downtime by facilitating effective remediation. Administrators can flexibly adjust compute resources and optimal checkpoint strategies to facilitate uninterrupted large-scale training jobs. If the RAS engine identifies that a replacement component is needed, standby capacity is activated to ensure work finishes on time with the least performance degradation. Any hardware replacements that are required can be scheduled to avoid unplanned downtime. All right, so now this is the NVIDIA Grace Blackwell Ultra and the Blackwell NVL72 rack scale system. These are the specifications for both. The rack configuration is the 72 Grace Blackwell Ultra GPUs. Compute trays are 18. And this is comparing the 300 to the 200. So both have 18 compute trays, both have NVLink switch trays, 9 of those. Both have 4 Blackwell GPUs and 2 Grace CPUs. Both have 72 rack GPUs to 36 CPUs. The Tensor Core for 300 has 1080 versus 720 and 1440. All right, Tensor Core. So this is where we see the difference here. HBM memory architecture. They both have HBM 3E in the 300. The memory size is 20 terabytes, and the 200 is 13.5 terabytes. HBM memory bandwidth. $576 for both. Fast memory, 36 terabytes, up to 31 terabytes for the 200. NVLink switch, both 9 NVLink switches. NVLink bandwidth bidirectional, both provide 130 terabytes per second. CPU cores, 2592 ARM Neoverse V2 cores, they both have that. So you see the rack here, the Grace chip, the Blackwell Ultra chip. Blackwell Ultra GB300 NVL. I think that's supposed to be NVL72. Hey, there is a typo in their document. Anyway, moving on. The NVIDIA GB300 NVL72 connects 36 Grace CPUs and 72 Blackwell Ultra GPUs in a rack scale design, supercharging inference, training, and data processing. The GB300 NVL72 is a liquid-cooled rack scale solution that boasts a 72 GPU NVLink domain that acts as a single massive GPU and delivers optimized connectivity built for AI reasoning. And understand that, right? Because of NVLink and all of these GPUs acting as one, that's why it says it acts like a single massive GPU. Maximizing AI factory performance and revenue, boosting AI factory output by 50%. Jensen Huang framed the Pareto frontier curves as an optimization framework for AI factory large language model inference, balancing throughput per megawatt against per user latency experience. Throughput per megawatt against per user latency experience. AI factory efficiency is a balance of the raw throughput. This is what I was sharing that he talked about before. Is a balance of the raw throughput and the fast response, with the optimal operating point being at the corner of the curves. The factory output can be viewed as the area under the curve, or approximated by the box area created by the balance point. Okay, so it's referring to the diagram below. NVIDIA Dynamo acts as a real-time orchestrator that dynamically partitions GPU resources across GPUs, GPU memory, and NVLink, enabling systems to fluidly navigate the Pareto curve rather than being locked to fixed operational points. By optimizing parallelization strategies and management across Blackwell Ultra GPUs, Dynamo achieves 50 times more AI factory output or productivity compared to Hopper, while maintaining low latency, maximizing revenue per token through efficiency token manufacturing. Give me a second here. I'm adjusting the computer. My neck is beginning to crook. Lowering TCO through performance and energy efficiency, boosting performance by 35 times. The NVIDIA GP300 NVL72 has a 35 times inference performance boost that transforms the speed and scalability of AI applications when compared with H100 for AI reasoning, enabling more complex strategic problem solving by AI chatbots. You know, one thing that I see in this is that NVIDIA is really many times comparing itself to itself. So this chip is not being compared to an AMD chip. It's not being compared to an Intel. It's not being compared to anybody else. It's being compared to itself because it had already set the standard with its previous chips. Just interesting note. So the output tokens per second per GPU. So the HGX H100, and then if you compare the GB300, 35 times more. GB300 delivers 35 times performance improvement for AI reasoning. Increased energy efficiency by 30 times. Data centers running AI workloads are often constrained by energy and cooling limitations. That's true, making efficiency a critical factor, with the goal of maximizing the performance for every unit of energy consumed. Blackwell Ultra delivers 30 times higher energy efficiency than the Hopper generation, lowering TCO by 25%. Total cost of ownership, or TCO, continues to be a focus of enterprises seeking to achieve significantly higher AI performance at a fraction of the cost. With GB300 and NVL72, customers will benefit from reduced hardware expenses in addition to minimizing cooling and maintenance costs over the lifecycle of AI deployments. This enables organizations to allocate resources more effectively, accelerating AI-driven innovation without excessive capital expenditure. So the energy use is decreased by 30 times, which is crazy, and the total cost of ownership by 25 times. End-to-end AI acceleration at rack scale. With up to 279 gigabytes of HBM3E memory. Let me adjust my mic. With up to 279 gigabytes of HBM3E memory per GPU, and 37 terabytes of high-speed memory per rack, coupled with over an exaflop of FP4 compute and a 72 GPU unified NVLink domain. Blackwell Ultra supports much higher models and can scale up with fewer nodes, opening the door to breakthroughs in AI. Combined with CUDA-X libraries for accelerated computing, NVIDIA accelerates the entire hardware and software computing stack, optimized for every data center. Investing in optimized data centers is not just a performance advantage, it's a strategic necessity for organizations looking to stay competitive in the AI-driven future. With 65 times more AI flops than HGX H100, GB300 NVL72 enables significantly more inference for AI models. By combining CPU with the GPU and high-speed interconnects by NVLink, data transfers across multiple systems have never been more efficient. Accelerated networking platforms. Next paragraph. Accelerated networking platforms for scalable, secure, and high-throughput AI performance. GB300, acting as a single extremely powerful unit of computing, requires robust networking to achieve optimal application performance. Paired with NVIDIA Quantum X800 InfiniBand, Spectrum X, Ethernet, Connect X SuperNICs, and Bluefield 3 GPUs, GB300 delivers unprecedented levels of scalable performance, efficiency, and security in massive scale AI data centers. With 800 gigabytes per second of total data throughput available for each GPU in the system, GB300 NVL72 seamlessly integrates with NVIDIA networking platforms, enabling AI factories and cloud data centers to handle trillion parameter models without bottlenecks. The GB300 NVL72 architecture is the first to introduce PCIe Gen 6 connectivity between GPU and Connect X8 SuperNICs, thus eliminating the need for a standalone PCIe switch interface. Connect X8 SuperNICs enable exceptional inference performance. The new NVIDIA Connect X8 SuperNIC provides a full 800 gigabytes per second network connectivity for each GPU in GB300 NVL72 systems. This delivers best-in-class remote direct memory access, or RDMA capabilities, with either NVIDIA Quantum X800 InfiniBand or Spectrum X Ethernet networking platforms, enabling peak AI workload efficiency. In one of my videos, we talked about RDMA as being a really great innovation, bypassing, kernels, and this is something that they've been doing a lot in InfiniBand, and they made in Ethernet, made available in Ethernet as well. And so great technology there. Additionally, the Connect X8 SuperNIC supports line speed network encryption for Internet Protocol for IPsec, or Internet Protocol Security, and PSP Protocol Security, or PSP, bolstering the platform's security with GPU to GPU connection encryption. Accelerating real-time video generation and multimodal AI capabilities by 30 times. Unlike state-of-the-art LLMs, which operate within a context window of only 128,000 tokens, a single 5-second video generation processes 4 million tokens, requiring nearly 90 seconds to generate on today's state-of-the-art NVIDIA Hopper GPUs. The Blackwell Ultra platform enables real-time video generation from world foundation models like NVIDIA Cosmos, providing a 30 times performance improvement versus Hopper generation, and allows customers to create customized, photorealistic, and temporarily and spatial stable video and 3D world simulators for their physical AI applications. More videos that you're not going to be able to tell the difference of who's actually, if it's the actual person or if it's an AI. Blackwell GB200 NVL72, maximizing AI factory performance and revenue. Boosting AI factory output by 40 times. The frontier Pareto curves illustrate the AI factory inference productivity balancing the throughput of single user response time. NVIDIA Dynamo enhances productivity by up to 40 times on a GB200 compared to Hopper systems. With real-time GPU resource orchestration, parallelization, and management of Blackwell GPUs, enabling maximum efficiency in token manufacturing in a fixed power condition of 1 megawatt. 1 megawatt. So before we were looking at the GB300, and now this is for the GB200. The 200 introducing cutting-edge capabilities and a second-generation transformer engine that significantly accelerates LLM inference workloads, enabling real-time performance for resource-intensive applications like multi-trillion parameter language models. GB200 NVL72 delivers a 30 times speed up compared to H100 with 25% lower TCO and 25 times lower TCO and less energy. It's the same number of GPUs for massive models such as GPT MOE 1.8. This advancement is made possible with a new generation of tensor cores, which introduces new precisions, including FP4. Additionally, the GB200 utilizes NVLink and liquid cooling to create a single massive 72 GPU rack that can overcome communication bottlenecks. The GB200 is a revolutionary solution for high-performance inference tasks, showcasing NVIDIA's commitment to pushing the boundaries of AI. There's a diagram that indicates that or illustrates that. GB200 includes a faster transformer engine featuring FP8 precision and delivers 4 times faster training performance for large language models like GPT MOE 1.8 terabytes compared to NVIDIA Hopper GPU generation. The performance boost provides a 9 times reduction in rack space and a 3.5 times reduction in total cost of ownership and energy usage. This breakthrough is complemented by the 5th generation NVLink, InfiniBand networking, NVIDIA Magnum IO software. Together, these ensure efficient scalability. For enterprise and facilitate the implementation of an extensive GPU computing clusters. Can you hear my neck cracking on this? All right. Accelerating data processing and physics-based simulation. GB200, with its tightly coupled CPU and GPU, brings new opportunities in accelerated computing for data processing and engineering design and simulation. Databases play critical roles in handling, processing, and analyzing large volumes of data for enterprises. GB200 takes advantage of the high bandwidth NVLink C2C and dedicated decompression engine in Blackwell to speed up key database queries by 18 times compared to CPU, resulting in 7 times less energy and 5 times lower TCO. Physics-based simulations are still the mainstay of product design and development. From silicon chips to pharmaceuticals, testing and improving products by simulating them rather than performing physical testing saves billions of dollars every year. Application-specific integrated circuits are designed ASICs are designed almost exclusively on CPUs in a long and complex workflow, which often includes and analog analysis to identify voltages and currents throughput. The Cadence Spectra X simulator is one example of a solver and runs 13 times faster on a GB200 than on an x86 CPU. GPU accelerated computational fluid dynamics is a critical tool for engineers and equipment designers to study or predict the behavior of their designs. Cadence Fidelity, a large eddy simulator, or LES, runs simulations up to 22 times faster on GB200 than on x86 CPUs. Sustainable computing. Compute density and compute power are driving transition from air to liquid cooling. Using liquid instead of air has many positive impacts inside and outside the data center, including high performance per rack, reduced water consumption for cooling, and allowing data centers to run at higher ambient air temperatures, which further reduces energy consumption. AI-ready enterprise platform. NVIDIA AI Enterprise is the end-to-end software platform that brings generative AI into reach for every enterprise, providing the fastest and most efficient runtime of generative AI foundation models. It includes NVIDIA NIM, inference microservices, AI frameworks, libraries, and tools that are certified to run on common data center platforms, and mainstream NVIDIA certified systems with NVIDIA GPUs. Enterprises that run their businesses on AI rely on the security, support, manageability, and stability provided by NVIDIA AI Enterprise to ensure a smooth transition from pilot to production. Together with NVIDIA Blackwell Ultra Accelerated Computing, NVIDIA AI Enterprise not only simplifies the building of an AI-ready platform, but also accelerates time to value. Learn about AI workflows with NVIDIA AI Enterprise by buildnvidia.com. NVIDIA Blackwell HGX. The NVIDIA Blackwell HGX B300 and B200 systems include groundbreaking advancements for generative AI, data analytics, and high-performance computing. The HGX B300 is built on the age of AI reasoning and enhanced compute and increased memory, featuring 7 times more AI compute than the Hopper platform, over 2 terabytes of HBM3E memory, and high-performance networking integrations with NVIDIA Connect X8 SuperNICs, and HGX B300 delivers breakthrough performance on the most complex workloads, from training, agentic systems, and reasoning to real-time video generation for every data center. The HGX B200, a Blackwell x86 platform based on 8 Blackwell GPUs base board, delivering 144 petaflops of AI performance. HGX B200 delivers the best performance for x86 scale-up platforms and infrastructure. Each GPU is configurable up to 1,000 watts per GPU. All right, I'm not going to go through this entire chart here. NVIDIA Blackwell architecture's role in the age of AI reasoning. AI has evolved to need three distinct scaling laws that describe how applying compute resources in different ways impacts model performance. Pre-training scaling, post-training scaling, test time scaling, or long thinking. All right. So pre-training scaling. The original law of AI development, it demonstrated that by increasing training data set size, model parameter count, and computational resources, developers can expect predictable improvements in model intelligence and accuracy. Pre-training scaling led to models that achieved groundbreaking capabilities. It spurred major innovations in model architecture, including the rise of billion and trillion parameter transformer models, growing 50 million times in 5 years in compute requirements. Post-training scaling. While pre-training scaling teaches a model the knowledge of the internet, post-training teaches a model how to think and furthermore improves a model's specificity and relevance for an organization's desired use case. While pre-training is like sending an AI model to school to learn foundational skills, post-training enhances the model with skill applicable to its intended job. To support post-training, developers can use synthetic data to augment or complement their fine-tuning dataset. The total compute required for post-training is 30 times more than the compute required for pre-training. That's a good highlight to note. Test time scaling, also known as long thinking or reasoning. LLMs generate quick responses to input prompts and can provide the right answers to simple questions, but it may not be as effective for complex queries. An essential capability for agentic AI workloads requires that LLMs to reason through the question before coming up with an answer, right? Which takes place during inference. Models using test time scaling are estimated to require 100 times more compute when compared to traditional inference, allowing them to reason through multiple potential responses before arriving at the best answer. So it's like the AI is learning, and then AI reasons coming up with an answer. But then it's actually being accountable to itself by checking and comparing the answers, several different answers that it's gotten, and then coming up with what is considered to be the best answer or the best solution per the input that was given. NVIDIA Blackwell is a once-in-a-generation platform with the compute capacity and energy efficiency needed to effectively serve the 3 scaling laws as the foundation for the age of AI reasoning. All right, and we're going to just read the appendix and then we're going to be finished. Appendix A, Advanced Parallelism Techniques in AI Inference for Trillion Parameter Models. Deployment of trillion parameter models like GPT 1.8 terabyte MOE, a mixture of experts like that, presents unique challenges in AI inference, particularly in managing computational resources effectively while ensuring optimal user experience. The appendix explores the various parallelism techniques, that word parallelism techniques that can be employed to address these challenges, focusing on data, tensor, pipeline, and expert parallelism. Parallelism techniques in AI inference. Data parallelism involves hosting multiple copies of the entire model across different GPUs or clusters, processing independent user requests simultaneously. This approach scales linearly with the number of GPUs, enhancing throughput without impacting user interactivity. However, it requires significant memory as each GPU holds a complete model copy. Tensor parallelism. Tensor parallelism splits each layer of the model across multiple GPUs, allowing different parts of a user request to be processed in parallel. This method can improve user interactivity by allocating more resources per request, thus reducing processing time. However, it relies heavily on high bandwidth inter-GPU communication, which become a bottleneck at large scales. Pipeline parallelism. In pipeline parallelism, different groups of model layers are distributed across GPUs, with each part of a user request processed sequentially across the pipeline. The technique helps manage large models by distributing weights, but may lead to inefficiencies in processing and does not significantly enhance user interactivity. And expert parallelism. Expert parallelism routes requests to specific experts within the model to different GPUs, reducing the interaction with unnecessary parameters. The results after expert processing require all-to-all communication over high bandwidth GPU interconnects. It requires complex management of data routing and reassembly, and its effectiveness is limited by the number of available experts. So now combining parallelism techniques. Combining different parallelism methods can mitigate the limitation of individual techniques. Using both expert and pipeline parallelism can double user interactivity with minimal loss in throughput. Similarly, integrating tensor, expert, and pipeline parallelism can triple GPU throughput without sacrificing user interactivity. Combining different parallelism for the right deployment scenario is an exhaustive solution space exploration. Combining different parallelism for the right deployment scenario is an exhaustive solution space exploration and requires a large set of compute resources. Maximizing throughput and managing operational phases. Efficient management of the prefill and decode phases, that is, context processing and generative phase, is crucial for maximizing throughput. Techniques like in-flight batching and chunking can optimize GPU utilization by allowing dynamic management of request processing, preventing bottlenecks during these phases. In-flight batching and chunking. In-flight batching and chunking are critical techniques for optimizing GPU utilization and enhancing user experience in the deployment of LLMs. These methods address the operational phases of AI inference, prefill, and decode by managing how data is processed across GPU resources. Chunk size consideration. The size of the chunk plays a pivotal role in balancing GPU throughput and user interactivity. Large chunk sizes reduces the number of iterations needed during the prefill phase, leading to a quicker time to first token. However, this also extends the duration of the decode phase, lowering the tokens per second rate. Conversely, smaller chunk sizes facilitate faster token output, enhancing TPS, but increases TTFT. This trade-off is crucial in determining the optimal chunk size for specific deployment scenarios. Impact of chunk size on GPT 1.8 trillion MOE model. Using the GPT 1.8 trillion MOE model as an example, the effect of varying chunk sizes from 128 to 8,192 tokens was analyzed across more than 2,700 combinations of parallelism and chunk length configurations. This extensive analysis helps in understanding how different settings impact the balance between throughput and interactivity. So I wonder what it showed there. Conclusion. The deployment of trillion parameter models requires sophisticated parallelism strategies to balance throughput and user interactivity effectively. By understanding and implementing a combination of data tensor, pipeline, and expert parallelism, enterprises can optimize their AI inference deployments to meet both computational demands and user expectations. For further insights into this, large-scale models, and deeper dive into different types of parallelism, this is the link, which I actually think I will read at another time. All right. So that was it. That was a long one. That was a good one, though. And so hope you enjoyed it. And again, this is Vernon Neil Reed with AI Infrastructure Media. Again, this was not necessarily an article, right? Where did I go just now? Yeah, this wasn't necessarily an article. This was an NVIDIA Blackwell architecture technical brief. And yeah, I enjoyed it. I learned a lot. And based on this, there's some other things that I want to read up on, and I'll share with you on that. Hope you're having a great day. Take care.